Good morning, everyone. Today I will talk about result presentation in GeoDict, transforming data into insights. As you may know, GeoDict can be used to simulate composite and porous materials, and using different kinds of modules for that, simulating different kinds of properties or measuring different kinds of structure characteristics. And ultimately, we aim to align to 4 overarching goals using GeoDict, which is see, measure, understand, and optimize. We want to see how the structure looks inside. We want to measure certain properties, and then we want to understand why our material behaves like it does. And finally, we optimize our material to get something better and something newer. In this talk, I will not tell about optimization. I will more or less tell you how to see, measure, and understand using GeoDict. Well, you see with the visualization features of GeoDict for sure. Here on the left side, you can see some different visualizations of volume fields or of your structure in 2D or in 3D view. You measure everything in GeoDict using property predictors or simply by measuring some distances in your image, which is here under the point of reports in the middle. Basically some numbers, but that's what you want. And then finally understand. I brought here some images of some plots because those will show you how your material behaves in different situations and makes it visible for everyone to understand. Well, my talk is titled From Data to Insights, but what exactly is data in this case? What is input data for GeoDict? Basically, there are 2 main options. Either you have 3D object data ready, or you have some statistics about your material. In the case of 3D object data, here comes in mind some 3D imaging from micro-CTs or a 3D file from your CAD software. And you would then import this data to generate a 3D structure to work on later. If you do not have any 3D object data, you surely have some idea how your material is made. For example, you have some manufacturing parameters, or you have some measurements from your experiments. In the perfect case, you have a digital twin of your material. You know everything about it, all the statistics, all the fiber lengths, or, for example, you know how your weaving matrix of a woven material looks like. You take all this data and convert it into some 3D voxel structure. As I said, you can import your 3D object data, or you can use structure generation if you have some structure statistics ready. But then, basically for each material, whatever you have, you are starting with this 3D voxel structure and put it through property prediction with GeoDict. And this again has really many different modules here, really different simulations or measurement types. And whatever comes out from property prediction is some result. And now comes the question, how can you get some insights from these results? And this is where result visualization and analysis in GeoDict comes in. I will now give some overview of the features of GeoDict that let you see data and analyze its contents. So first thing that comes popping up after your simulation is finished is the result viewer, like you see here. It simply visualizes the most important numbers. You can, for example, see the permeability that you have just simulated. If you are interested in all the details, no problem, because all the numbers, all the measurements are saved in the GDR file, and you can simply access them. That's okay. But numbers are a little bit boring and hard to look at, so we have also some plots implemented. Visualize all your data using these plots. It can be simple XY plots. It can be 2D heat map plots, a little bit like a two-dimensional view in GeoDict. Or it can be a little bit more complicated, like this polar coordinate plot here on the right-hand side, which is, for example, showing some orientation data. Use our exporting features to simply get your data over to other programs like Excel, or open it in your browser, or even simply print it out using a PDF export. Some of the result files offer this automated result video generation. Here you have a one-click solution to simply generate something like this here. Here you see a flow field simulation and its automated video presentation. Next basic feature that combines almost anything useful in GeoDict to show is the visualization in 2D and 3D. You can see here some structures in the two-dimensional view and a three-dimensional view. You can change colors for sure. You can customize everything to your needs. You can even tell the visualization to show a smooth view, like shown on the right picture, where there are no voxels visible anymore. It just seems like a smooth surface. If you choose the correct settings, you can even make the two-dimensional view look like an SEM image. You can surely change colors of your structure, highlighting some important parts of it, or simply matching the colors to your corporate identity. Next big feature is showing volume fields. If you simulate and have some results that are also three-dimensional aligned, then you have to somehow have a look at them. And here I brought some examples. Here you have, for example, object labels that come from identification of fibers. Or here you have a velocity field from a FlowDict simulation that simply tells you how fast is your flow through your structure. Or here you can see the diffusion flux inside a battery cell, or here something easy, the deposited dust that comes from the FilterDict simulations. But when it comes to flow, there's not only the velocity that you see here, you surely want to see the directions. No problem, we have streamlines or arrow visualization for this case. And then finally, you can also visualize tensors. Here is an example from a tensor, which is the strain field from a mechanical simulation. For dealing with filtration, in FilterDict, or maybe in AdiDict with molecules, you will come across the particles. This can also be visualized, and you can see here the trajectory of each particle that hits a fiber somewhere and will stick to its surface. Importing and exporting of CAD files comes with importing triangles or polygons. Those can surely also be visualized, as you can see here. As an example, I exported some weave structure So you can see on the left side there is the voxelized structure, and on the right-hand side you see the mesh that has been exported. You can surely check its quality simply in our 3D viewer. Apart from the automated result video generation, Geodict also offers a little bit more complicated video editor, which lets you create your own videos. I have brought an example of how that looks like. So here on the right-hand side, you see the editor having different properties that change over time. And on the left-hand side, you can see how this affects the image that you see. You can change, more or less all visualization properties using this editor, be it colors of your structure, camera orientation or direction, or simply cropping your structure in and out. And then export this and have this video ready for your presentations. The result viewer features further analysis in form of post-processing. Here you see a window with some post-processing options on the left-hand side. You can change values here and run post-processing, and then, for example, update some plots or tables showing new data or showing different statistics that are based on some value of your interest. You can also prepare volume fields that you can load after that and show it in your three-dimensional visualization. If you compare different results from or varying results from maybe some simulations where you change velocity, for example, you can also do that in the result viewer. Here you see 3 different results next to each other. But you can also choose the files in the combine GDR, which lets you compare all the data in one table, and then finally also combine all the plots into one, which lets you easily understand differences between your simulations. And last but not least, there are some measurement tools in Geodict. First off, which has been noted to be somewhere else now. Here on the left-hand side, the statistics have now moved from the upper part of the Geodict main window to the left side in this tree, which tell you, for example, percentages of your material IDs that you are currently looking at, or also object numbers or some grammage and all these statistics. Also, don't forget, if you have a volume field loaded in 3-dimensional or 2-dimensional view, if you simply mouse over it, you will get information about the position that you are currently pointing at. Also, we have a measurement tool that lets you measure distances and angles in the 2-dimensional view. And for the volume fields, we have field metrics, which, for example, here in this case, lets you calculate the slice averaged mean values of a field. Let me show you some application examples of how these visualization tools have been used. First, here I have a FIBSEM scan analysis of a battery cathode. Here we analyze this active material grains to see the microstructure and morphology, can do some elemental mapping, we see the particle size and distribution, and we can even see some cracks and defects. Input data for this example here is a FIBSEM scan, so a gray value image that we just imported into Geodict. And here is the result. Here on the left side, you see we have the segmentation of this scan, and we can easily understand what is binder and what is active material. And if we go further and use the identify grains on this, we have simple coloring for each grain. And on the top, you may see there is one grain that is colored in 4 different colors because it's cracked in smaller parts. Next example here is the mercury intrusion capillary pressure. You may have seen that already yesterday. We here compute the digital MICP, and we can measure pore size distribution and connectivity and even unresolved porosity. It looks something like this. Also a really nice visualization of this process where mercury is pushed into the rock sample to fill up the pore space step by step. Yeah, and this is the result of this simulation. Here on the left-hand side, you can see measurements in gray, and red denotes the GeoDict simulation. And on the right-hand side, this data is coming everything from GeoDict. So here the gray line is our Tomer fit, which lets us see the unresolved porosity and even measure that in GeoDict. And last example here is the simulation of reactive flow in GeoDict. We here computed dissolution and precipitation of a mineral phase to understand basically how the permeability reduction and enhancement works, how the porosity permeability relationship looks like. So in basically we have here a 4D rock alteration, 3D alteration over time, and have a look at that. It looks a little bit like this here. You can see from the left is coming some flow going through the rock and dissolves some parts of this rock shown in red. And here we have used our combined GDR features, which lets us combine the plots like shown here, and shows us these beautiful differences between using different injection velocities, and lets us understand how the porosity changes based on different kind of regime. Let me conclude. From input data to insights, I've shown how the input data is loaded into GeoDict, and then how we can get some insights from the results after our property prediction. We can see the structure, the grains, the fibers. We can measure pore space and structure statistics, and we can understand the effects of structural or parameter changes. And finally, we can then use these insights to create some superior material. Also, remember, you can customize your visualization so that it fits your needs. Create clear and scientific plots, use scalar fitting for your structure and your volume fields, export to your PDF, Excel, or videos to match your needs. And if that all is not enough, we also have GeoApps that provide even more flexibility. Use our Python API to access result files, change visualization settings, and then do automated exports of plots, images, and videos. Thank you.